Everyone. Today we discuss class 11 physics most important chapter work, energy and power completely. So first we discuss the nature of work done. The nature of work done is positive work done, negative work done and zero work done. The SI unit of work done is joule. 1 joule is equal to 1 Newton into 1 meter is equal to 1 kg meter per second square into 1 meter. 1000 gram into 100 centimeter into 100 centimeter per second square is equal to 10 to the power 7 gram centimeter square per second square is equal to 10 to the power 7 arc. So we can say 1 joule is equal to 10 to the power 7 arc. The SI unit of force is Newton. 1 Newton is equal to 1 kg into 1 meter per second square is equal to 1000 gram into 100 centimeter per second square is equal to 10 to the power 5 dyne. So we can say 1 Newton is equal to 10 to the power 5 dyne. Here numerical. A gardener pushes a town Rolex through a distance of 20 meter. If he applies a force of 10 Newton in a direction inclined to 60 degree to the ground, find the work done by the gardener. So here distance is equal to 20 meter, force is equal to 10 Newton and theta is equal to 60 degree. We know work is equal to Fs cos theta. So 10 into 20 into cos 60. The value of cos 60 is half. 10 into 20 into half 100 joule. Here a dot product problem. A force F is equal to I cap plus 5j cap plus 7k cap acts on a particle and displaces it through S is equal to 6I cap plus 9k cap. Calculate the work done. Here F is equal to I cap plus 5j cap plus 7k cap. S is equal to 6I cap plus 9k cap. So if we know dot product, and this numerical is very easy. Same question. Now we discuss work. What is work and when a work is done. Work is said to be done when force is applied on a body and the body moves through some distance in direction of force. And 1 Newton is equal to 10 to the power 5 dyne. 1 meter square is equal to 10 to the power 4 centimeter square. Here same dot product numerical. Here work done by variable force. Same question. Now we discuss energy. Energy is capacity or ability to do work. The SI unit of energy is joule. Dimension formula is ml square t minus 2. Mechanical energy is equal to kinetic energy plus potential energy. Kinetic energy is energy posed by a body by virtue of its motion. Potential energy by a body by virtue of its position. Here kinetic energy derivation. Kinetic energy is equal to half mv square. Kinetic energy by calculus method. Very important topic. First, we consider a body of mass m initially at rest. D force F is applied on the body, which produce displacement ds in direction of force. So work done dw is equal to fds is equal to fds cos theta is equal to fds. According to Newton's second law of motion, F equal to ma is equal to m dv by dt. Using 2 in 1, dW is equal to mdv by dt ds is equal to mdv ds by dt is equal to mv dv. So total work done, W is equal to integration of dW. Here relationship between kinetic energy and linear momentum. We know linear momentum P equal to mv. Kinetic energy is equal to half mv square into m by m, half m square v square divided by m, p square 2m. Kinetic energy is equal to p square by 2m. Now we discuss work energy theorem. It states that the work done by net force acting on a body is equal to the change in kinetic energy of the body. Derive proof. Let us consider that a constant force F acts on a body of mass m and produce acceleration a in it. After covering a distance s, the velocity of the body changes from u to v. Now we have v square minus u square is equal to 2as. Multiplying both sides by half m, we got half mv square minus half mu square is equal to half m 2as. As per Newton's second law of motion, F equal to 2ma. Half mv square minus half mu square is equal to 2ms. Kinetic energy final minus kinetic energy initial is equal to work done. Proof for variable force. This is variable force proof. Let us assume that a variable force F act on a body of mass m and produce displacement ds in a one direction. So small work done is given by dw is equal to f ds is equal to f ds. dw is equal to f dot ds is equal to f ds. As per Newton's second law of motion, according to Newton's second law, F equal to ma m dv by dt. Using equation 2 in 1, we got dw is equal to m dv by dt ds. M dv ds by dt is equal to mv dv. Total work done, integration kinetic energy final minus kinetic energy initial. Gravitational potential energy. Energy posed by a body by virtue of its position above the ground. Now we discuss what is conservative force. A force is said to be conserved if the work done by the force is displaying a particle from one point to another is independent of the path followed by the particle and depends only on the endpoints. Now prove that work done by a conservative force along a closed path is zero. This is very important question. If we prove, we let suppose a particles move from point A to point B along path 1 and path 2. If the force is conservative, mathematically WAB along 1 is equal to WAB along 2. Now let us assume that the particle moves from A to B along path 1 and then back from B to A along path 2. Work done on particle along path 2 from A to B is equal to minus of work done on particle along path 2 from B to A. WAB along 2 is equal to minus WBA along 2. WAB along 1 is equal to minus WBA along 2 from 1 equation. WAB along 1 plus WAB along 2 is equal to 0. W along closed path is equal to 0. So we prove. Potential energy in relation to conservative. Only in case of conservative force, minus del U is equal to W. Now we discuss principle of conservative of mechanical energy. This principle states that if only the conservative forces are doing on in body, its total mechanical energy remain constant. How we can prove? We suppose a body undergoes displacement del x under the action of a conservative force Fx. Fx del x is equal to del k, as force is conservative. Fx del x is equal to minus del u. Comparing equation 1 and 2, del k is equal to minus of del u. Kinetic energy final minus kinetic energy initial is equal to minus uf minus ui. Kinetic energy final minus kinetic energy initial is equal to minus of uf plus ui. K dot ef plus uf is equal to k dot ei plus ui. Mechanical energy final minus mechanical energy initial. This is conservation of mechanical energy for a freely falling body. Important topic. Now we understand collision. Collision is said to occur between two bodies, either if they physically collide against each other or if the path of one is affected by the force exerted by the other. The types of collision is two: elastic collision and inelastic collision. If there is no loss of kinetic energy during collision, it is elastic collision. If there is loss of kinetic energy during collision, it is inelastic collision. Momentum is conserved. Total mechanical energy is conserved. Total energy is conserved. Elastic collision in one dimension. This is very important. We consider two perfectly elastic bodies A and B of masses m1 and m2 moving along the same straight line with velocity u1 and u2 respectively. Let u1 greater than u2. After some time, the two bodies collide head on and continue moving in the same direction with velocity v1 and v2 respectively. After collision, v2 greater than v1. As per conservation of linear momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. Dividing 3 by 2. So u1 plus v1 is equal to v2 plus u2. Now we understand when work is positive. Work is positive when the force applied and the displacement are in the same direction. Example, pushing a moving car forward. Negative work done. Work is negative when the force applied and the displacement are in opposite direction. Example, friction force while a car moves forward. Zero work done. Power rate of doing work. SI unit of power is watt. 1 watt is equal to 1 joule by 1 second. Dimension formula is ml square t minus 3.